So welcome to Electronics Lecture, and you are watching Digital Electronics Lecture Series. So today the topic of discussion is the RS latch using the NAND gates. So in the previous lecture, we have seen how the RS latch can be constructed using the NOR gates. Also, we have seen how it operates with different combinations of inputs. Today, we'll discuss about this RS latch using the NAND gates. So we'll see how the RS latch can be constructed using the NAND gates. Then we'll see how the latch behaves with different combinations of RNS. Okay. So let us start our discussion. So it is the simplest type of latch. The RS latch is the simplest type of latch. It has two inputs which are labeled as R and S. So R stands for reset and S stands for set. The two outputs are Q and complement. Q complement. For normal operation of any latch, the Q and Q bar should be complement to each other. Okay. So it can be constructed using the two cross-coupled NAND gates. Okay. So we have seen what is cross-coupled. The output of one NAND gate is connected to the input of another NAND gate and vice versa. Okay. So the two NAND gates are cross-coupled so that the output of NAND gate number 1 is connected to the inputs of NAND gate number 2 and vice versa. So let us see the logic diagram of this latch. So we have two NAND gates are there. Okay. So this is the NAND gate number 1. This is the NAND gate number 2. Okay. So you can see the output of this one NAND gate. This is the first NAND gate is connected to the input of another NAND gate. Okay. Similarly, the output of NAND gate number 2 is connected to the input of NAND gate number 1. Okay. So it has the two inputs. One of the input is S and another input is R. Okay. So here the S is having the highest priority. Okay. So Q and Q complement are the two outputs. Okay, of this latch. So this for any normal operation of this latch, the Q and Q complement should be complementary to each other. Okay. So the difference between the this NOR gate latch and NAND gate is that using this two NAND gates, we can have active low RS latch. Okay, so we can construct the active low RS latch using the two NAND gates. So previously, using the two NOR gates, we have constructed the active high RS latch. But in this case, we will be constructing active low RS latch. Okay, what is active low? Active low means for this R value is 0 and S value equal to 1. Okay, this will reset the latch. Okay, reset the latch means the output Q will be 0. Okay, similarly for this is a Q. Okay, for 1 and 0. So if the set value is 0, okay, the set value is low, active low, this will set the latch. Okay, that is the output will be 1. Okay, so the active low value of reset will reset the latch, and active low value of set will set the latch. Okay, so this is the that is why it is known as active low RS latch. Okay, it can be constructed by using the two NAND gates. Okay. So as I have told you that this R stand for reset and S stand for set. Okay, these are the two inputs of this RS latch. Okay, so this is the logic symbol of RS latch. So these are the two inputs. That is the S and R, and Q complement are the two outputs of this latch. Okay, so in the previous also using the NOR gate, we have seen that the logic symbol is same as that of this NOR gate and NAND gates. Both are same, and only difference is that RS latch using NOR gates, so we can have active high RS latch can be constructed. Okay, but in this case we can construct active low RS latch using the two cross coupled NAND gates. Okay, so let us see the operation of this RS latch with different combinations of R and S. That is the RS R and S values. Okay, so RS values can be 0, 0, 0, 1, 1, 0, and 1, 1. So we'll see how the latch behaves with the different combinations of that R and S. Okay, so let us see that. So what is the speciality of this NAND gate is that logic 0 at any input of the NAND gate, it forces the output to be logic 1. Okay, if we have any input of NAND gate is that is the 0, it forces the output to be 0. Okay, so this is a NAND gate. So NAND gate. And what is the means output of this NAND gate? So if A and B are the two inputs, okay. So the two inputs are A and B, then it will be A dot B, that is the complement. Okay. So this is the output of a NAND gate. Okay. So if the NAND gate is any input is 0, it forces the output to be 1. Okay. So you can see over the two input NAND gate. So 0 0. So for different combinations of A and B, 1 0, 1 0, that is the 1 0 1 and 1 1. Okay. So you can see if 0 0, what will the output? The output will be 1. Okay. If 0 1, what will the output? NAND gate output 1. 1 0, the output will be 1. 1 1, the output will be 0. So you can see if any input of the NAND gate is 0, so at least one input of NAND gate is 0, then it forces the output to be 1. Okay. So that is the speciality of this NAND gate. Okay. It is applicable for any input. Okay. So if logic 0 at any input of the NAND gate, it forces the output to be at logic 1. Okay. So that property we are going to apply in this case. Okay. So this is our case 1 when R is 0 and S equal to 1. So that is we will apply in this RS latch. Okay. So S value 1 and R value is 0. Okay. So S value 1. Okay. So S value is 1 and R value is 0. Okay. So S value means that is we are applying as 1. Okay. Here R is value we are applying as that is 0. So if any input of this NAND gate is 0, it forces the output to be logic 1. Okay. So suppose this is our NAND gate number 1. This is the NAND gate number 2. Okay. So you can see the NAND gate number 2 has the input as 0. So it forces the output to be 1. Okay. So in this case the output is 1. Okay. Then this 1 is connected, this QR is connected to this one of the input of this NAND gate number 1. So you can see this is 1 and 1. This NAND gate, the both inputs are 1 1. The output will be 0. Okay. So let us check once again. So S is 1 and R is 0. Okay. So any input of the NAND gate is 1 means 0 means the NAND gate 2. It accepts the input as 0. So that output will be 1. Okay. Then this QR is connected to the input of this NAND gate 1. So that this NAND gate 1 has the two inputs 1 and 1. So output will be 0. Okay. So that is the means this is called the reset condition. So when R equal to 0 and S equal to 1, the latch output is in the reset. So this is our case number 2 when R equal to 1 and S equal to 0. Okay. So we are applying now R value is 1 and S value equal to 0. So R value is 1 and S value equal to 0. So if any input of the NAND gate is 0, it forces the output to be logic 1. Okay. So this Q will be 1. Then this Q is connected to the one of the input of this gate. So 1 and 1, what will the output? The output will be 0. Okay. So let us see once again. So this is our NAND gate number 1. This is our NAND gate number 2. Okay. So we are applying the S value is 0 and R value equal to 1. Okay. So if any input of the NAND gate is 0, it forces the output to be 1. So this NAND gate, gate number 1, as the input is 0, so the output will be 1. Then this 1 is connected over here. Okay. So this NAND gate 2 accepts the two input as 1 and 1, the output will be 0. So this is known as your reset condition. Okay. So reset condition when R equal to 1 and S equal to 0, the large output in the large output in the set state. Set state means Q equal to 1. Okay. So let us see our third case when R equal to 1 and S equal to 1. So both the two inputs are 1 1 now. Okay. So we have to assume in this case Q equal to 0 and Q bar equal to 1. Okay. So S and R both are 1 1. Okay. So this is our suppose gate number 1. Okay. So this is our gate number 1. This is the gate number 2. Okay. So in this case, what we are doing is that we are assuming Q equal to 0 and Q bar equal to 1. Okay. So why are I assuming? Because if this gate number 1 is the input, suppose 1 0. So this is 1 and 0. What will the output? the output will be 1. Okay. Similarly, this if this value is equal to 1, okay. So 1 and 1, what will the output? 0. So we cannot predict this Q, okay, this output. Similarly, we cannot predict this Q, okay. That is why you have to assume, okay. So in the first case, we are assuming Q equal to 0 and Q bar equal to 1. So this 0, that is this 0 comes over here, okay, and this one comes over here, okay. So in this case, this is 1 and 0. So this NAND gate 1 has the inputs are 1 and 1. So the output equal to 0. Okay. Similarly, NAND gate 2, the inputs are 0 and 1. Output equal to 1. Okay. So whatever we assume, the same uh, we are getting. The same thing we are getting. Okay. So that is why in this case our assumption is true. Okay. Similarly, we are assuming now Q equal to 1 and Q are equal to 0. Okay. So S and R both are 1, 1. So this is our NAND gate number 1. Okay. This is the NAND gate number 2. Okay. So we are assuming now Q equal to 1 and Q are equal to 0. This one comes over here and this 0 comes over here. Okay. So in this case, this is 0. So 0, the NAND gate 1 has the inputs 1 and 0. The output will be 1. Okay. So in NAND gate 2, the inputs are 1 and 1. The output will be 0. Okay. So in this case, we can see it matched our initial assumptions. Okay. So in both cases, you can see that we have matched the initial assumptions. So that is why this state is called the no change state. Okay. So if R equal to 1 and S equal to 1, the latch remains latch in the last state. Okay. So let us see our last case, that is the when both the inputs are 0, 0. Okay. So now this NAND gate, both NAND gates have the inputs are 0 and 0. So what we have now, if any input of the NAND gate is 0, it forces the output to be logic 1 immediately. Okay. That is why the Q and Q complement both are, you can see 0, 0, 1, 1. Okay. So that is the why this condition is called indeterminate condition or invariant state. Okay, because Q and Q complement should be complementary to each other. Okay, in this case both are 1, 1. Okay, that is why this state is also called the prohibited state or no change state. Okay, so when R and S are 0, 0, the latch output in the prohibited states. Okay, so let us summarize in the form of the truth table. Okay. So R and S, the two inputs, and Q and Q complement are the two outputs. So what will be our state? So 0, 0, that is called the indeterminate state, okay, or the prohibited state. So in order to reset the latch, we have to apply R value is 0 and S, that is the S value equal to 1. Okay. So in order to set this latch, we have to apply R equal to 1 and S equal to 0. Okay. And if R and S value both are 1, 1, this is our no change state. Okay. So that is we have discussed the RS latch, how it can be constructed using the NAND gates. Then we will see for different combination of R and S, what will be our states. Okay. So these slides are prepared using these two books. One of the book is from Anand Kumar, okay, from PHI publication. The second book is from P. Raja, Skytech publication. Okay. So that's all. Stay connected to this channel and thank you for watching this video. So if you have any doubt, you can free to ask me in the comment section. Okay. So thank you all. Have a nice day.